Hello, and welcome to this week's presentation on depression, neuroplasticity, and neuroprogression. Depression is a common mental health disorder characterized by persistent feelings of sadness, hopelessness, loss of interest, and pleasure in activities. A person can be significantly impacted as it relates to thoughts, emotions, and behaviors. Depression is caused by complex factors including genetics, biological neurotransmitter imbalances, stressful life events, trauma, or environmental components. The affected parts of the brain in depression include the hippocampus, the amygdala, the thalamus, the prefrontal cortex, the caudate nucleus, the nucleus accumbens, and the hypothalamus. The symptoms of depression come from the functional and structural changes in these brain regions affecting a person's emotional regulation, behavior, thoughts, and actions. The prefrontal cortex is underactive and impaired in depression, causing decreased functioning. The amygdala is overactive, which is leading to the exaggerated fear response the person is experiencing. The hippocampus is smaller in volume, leading to memory impairment and forgetfulness. The hypothalamus is affected and creates sleep and libido dysfunction, while the caudate nucleus and nucleus accumbens of the striatum play a role in reward system motivation and reinforcement dysfunction. Understanding depression has evolved in research by viewing impaired neuroplasticity as a key component that is underlying in depression. The school of thought believes that the brain cannot adapt or change through new connections in a person suffering with depression. Simply stated, neuroplasticity is the ability of the brain's nervous system to adapt structurally and functionally based on new experiences. When the brain structure or function is altered, the outcome is clinical manifestations of disorders such as depression. Research has linked depression to dysfunction in the brain's ability to form new connections or adapt to change because of reduced neuronal growth or impaired synaptic plasticity. Depression is postulated to develop because the brain cannot form new neuronal connections or strengthen pre-existing ones in sensitive areas such as the prefrontal cortex or the hippocampus. Contributing factors include chronic trauma or negative environmental factors leading to this decrease in neuroplasticity, predisposing the brain to depression. The brain under chronic stress builds up glucocorticoids and damages neurons in brain regions, creating an uninhabitable environment for dendritic spines. Neuroprogression involves fundamental changes in neurons leading to pathology involving decreased neuroplasticity, neurogenesis, and dysfunction at the mitochondrial DNA level. This process is worsened with inflammation and an influx of calcium, thereby leading to neuroprogression, and this leads to the function and structural changes creating clinical manifestations of depression. Neuroprogression negatively impacts the brain related to a degeneration or deterioration of the brain's structure and function, which thereby creates symptom exacerbations and can lead to treatment resistance and must be treated before the damage becomes irreversible. Neuroplasticity is known as a regenerative process, whereas neuroprogression damages the synapses and neurons and is degenerative. So, for example, a neuron degeneration is created by a dysfunction in cell signaling, cell death known as apoptosis, decreased plasticity, and neurogenesis, which will halt the neuroplasticity and thereby contribute to depression. The clinical significance in the neuroprogression and depression is that there will be treatment resistance, there will be repeat exacerbations, and continued structural and functional decline, worsening depression. This can be reversible if treated in time before neurons are totally destroyed. Main properties and characteristics of neuroplasticity include neuroplasticity is highest at childhood, but the brain can adapt throughout the lifespan. This allows for neural pathway reorganization, new connections being formed between neurons, adaptation to environment based on new input, such as doing a task repeatedly that you're uncomfortable with, or playing a musical instrument, for example. And this will regenerate neurons. Changes occur by repetitive continued stimulation, brain changes in shape and function with new neuronal information, and this causes the rerouting, enhancing neuroplasticity. Neuroplasticity heals the brain after trauma and damage, and 5 characteristics include that it occurs throughout the lifespan, it is experience dependent, it is selective, reversible, and occurs at different levels of the brain. As you can see in the photo here, the rerouting is new connections being made between active neurons to create alternative neural pathways, and sprouting is when a new axon and dendrite extensions allow existing neurons to form new connections. So this would be all part of neuroplasticity. The main properties and characteristics of neuroprogression include that it is a mild degenerative process. It involves intracellular signaling, dysfunctions, apoptosis, decreased plasticity, and neurogenesis. So the depiction here shows that damage to cellular components are created by an induction of apoptosis, inhibited neuronal growth, and survival. This will create a cognitive and functional decline and increase the structural abnormalities, which will predispose the brain to even further damage or clinical manifestations of depression. This creates treatment resistance and increased vulnerability for further episodes or exacerbations. And major depressive disorder vulnerability is also predisposed by genetics or cell damage, as well as oxidative stress or psychosocial physical stressors from the environment. This is a cyclical process involving inflammation, epigenetic changes, neurotrophic disturbances, HPA axis dysregulation, mitochondrial dysfunction from the influx of calcium damaging the cell, and it just keeps going on in the way of neuroprogression until it becomes irreversible. Although monoamines play a role in depression, based on the neuroplasticity depression hypothesis, the primary neurotransmitters implicated is glutamate. And this glutamate interacts with the NMDA receptor, and the NMDA receptor has a critical role in regulating synaptic plasticity, and if it is dysregulated, this can cause impaired function in the brain as it relates to depression. Also, a crucial protein known as BDNF is vital in growth and survival of neurons. So typically in someone with depression, there is a decreased production of BDNF, and this also is relative to impaired neuroplasticity and prevalent depression. Even though the monoamine deficiencies contribute to depression, such as serotonin, dopamine, and norepinephrine, the neuroplasticity theory focuses on alterations in signaling pathways because of the impaired neuroplasticity creating the depressive symptoms. Of note, GABA also plays a role in the neuroplasticity, which acts as an inhibitory neurotransmitter, and this helps to regulate the activity of neurons, creating a balance of excitation and inhibition, which is crucial to brain function. And if the activity of GABA is reduced, depression symptoms are notable. So implications of this entire process are that damage is done to the brain structurally and functionally. So depression is what is creating the change in the structure and function of the brain. So neuroplasticity and neuroprogression play a role in depression, both good and bad. So drugs acting on GABA and glutamate systems can reverse the structural and functional brain changes if given at a time where the synapse is not completely lost. And if the patient does not respond to a typical antidepressant by way of just the monoamine theory of depression, there are other options including CBT or using GABA glutamate or non-monoaminergic targets. Also, increasing BDNF factors can positively treat depression. And Elevated serotonin in the synapse remodels dendrites, which can enhance neuroplasticity. And also glutamate facilitates reversible neural adaptations. So inhibiting glutamate will block the neuron remodeling in some areas of the brain. And lastly, the NMDA glutamate receptor agonist that has been recently introduced is a new treatment known as ketamine, which can contribute to the neuroplasticity and has been successful in treating depression. So just to sum up, a stressor is introduced to the brain, which can cause decreased or dysfunctional BDNF, as well as specific or particular mutations. So this dysfunction in the BDNF can cause a decrease in the synaptic plasticity, or it can increase the neuronal degeneration. So a decrease in synaptic plasticity will create decreased glutamate, which will then decrease the synaptic transmission and increase neuronal degeneration. And all of this cycle will lead to depression. And this slide is a slideshow of my references, and I hope you enjoyed my slideshow. Thank you.